Ph261 Chapter 8 Homework Problem Number 2. A 2.1 kilogram snowball is fired from a cliff 11.9 meters high. The snowball's initial velocity is 14 meters per second, directed 39 degrees above the horizontal. Include the signs of the value in your answer. So we're going to start, like always, by listing our givens. So we're given a 2.1, well, we can actually call this mass. Mass is 2.1 kilograms. We have a delta y, which equals 11.9 meters. And we have an initial velocity, which is 14 meters per second, and an angle theta, which equals 39.0 degrees. Okay. Or this is going to look like we have a cliff. We have a, I guess I'm going to say a person throwing a snowball here above the horizontal. It's going to form like a triangle, and this is going to be theta. And this is going to be, of course, like the force applied. So it wants to know the work. Work equals force times displacement. And it's going to hit the ground at some point. So that's going to be where we want. So that's the work done on it. Now it says work done by gravity. So it doesn't actually want the other work. So just the work done by gravity is going to be mass times gravity times the displacement times delta y. So mg, well, cosine. So we actually say cosine theta. Never mind, cosine theta. It would make more sense if I do delta y, cosine theta. And we plug in our values, so it's going to be 2.1 times 9.8. It's going to be times 11.9 cosine theta. And this is going to give us well, instead of cosine theta, we want the work done by gravity. If we have it pointed upwards, of course gravity would always be working against it. This is going to be cosine, just cosine of 0. So the work done by gravity in this case would be 244.9. The answers are already there. That's really funny, but what is the change due to gravitational potential energy? So gravitational potential energy is going to be the change in potential energy, which is minus, let's see. Yeah, minus work done by gravity. So that's work done by gravity. Change in potential energy is going to be negative work done by gravity. So this is part A, this is part B, and then part C, of course, asks if the gravitational potential energy is taken to be 0 at the height of the cliff, what is the value when the snowball reaches the ground? So we know that the gravitational potential energy is equal to mg delta y cosine or is equal to negative mgy delta y cosine theta. In this case, theta equals 0. So what this would be, instead, it would still be negative wg. So in this case, we can say that ug is equal to negative wg, same as change in potential energy, same as work done by gravity. So that is how you do chapter 8, homework problem number 2.